Welcome, friend. I'm so glad you're here. Tonight, we are going to leave the busy world behind and embark on a quiet, slow-paced journey through our home galaxy, the Milky Way. It is a place of immense beauty and profound stillness, a perfect landscape for the mind to wander as the body prepares for rest. Before we drift too far into the stars, I'd like to gently invite you to subscribe to this channel. These nightly journeys are created to help you find peace, and your support helps this quiet corner of the internet grow. If you find this relaxing, perhaps leave a soft comment when you wake. It is a lovely way to connect while keeping the atmosphere calm and supportive for everyone. For now, let's focus on the present moment. Find a position that feels entirely effortless. Adjust your blankets and settle into the warmth. Let your shoulders drop away from your ears. Let the tension in your jaw melt away. Take a slow, deep breath in, feeling your chest rise gently, and exhale slowly, feeling yourself sink deeper into the softness of your bed. As you lie there, imagine the ceiling above you slowly beginning to fade. The familiar lines of your room are blurring, turning into a deep indigo mist that eventually clears to reveal a magnificent dark sky. You are safe, warm, and perfectly supported by the ground beneath you. It is a remarkable thought that even in this stillness, we are moving. We are sitting on a small sapphire planet, spinning gently on its axis, while spiraling through a vast river of light. We are part of something much larger than ourselves, a cosmic dance that has been unfolding for billions of years. We often feel so stationary in our daily lives, yet we are truly voyagers, traveling through the silent depths of space at incredible speeds, held securely by the invisible hands of gravity. Feel yourself becoming lighter now. Imagine we are slowly lifting off, drifting upward away from the familiar sounds of the neighborhood. We are passing through the cool, crisp air of the lower atmosphere, leaving the glow of streetlights and the hum of the world far below. As we rise through the troposphere, the air becomes incredibly clear and still. The vibrant blue of the daytime sky has long since vanished, replaced by the first hints of the velvet blackness that lies beyond our world. We are standing on the threshold of the great silence, looking up at the shimmering band of light that marks the edge of our galactic home. The journey is just beginning, and the stars are waiting to tell their stories. As we continue to rise, the last remnants of the Earth's atmosphere thin out, and the vibrant blue light of the day, caused by the scattering of sunlight, begins to dissolve. It fades into a deep, bruised purple, then a charcoal gray, and finally, it settles into a magnificent velvet black. This is the true color of the universe, a darkness so profound that it feels like a soft weight, pressing gently against the senses, encouraging the mind to let go of the day's distractions. In our modern world, we rarely get to see the sky in its natural state. Astronomers use a measurement called the Bortle scale to describe how dark a night sky truly is. In the heart of a city, at a level 8 or 9, the sky is never truly dark. It is a hazy orange, and only the most stubborn, brightest stars can be seen. But as we drift into the quiet, uninhabited parts of our imagination to a level 1 on the scale, the sky transforms. It is no longer a ceiling, but a window. In this pristine darkness, the stars do not just twinkle, they burn with a steady, ancient light, and the sky feels crowded with possibilities. Stretching across this vast, dark canopy is a soft, glowing ribbon of light. It is irregular and ethereal, arching from one horizon to the other like a path of silver dust. To the ancient Greeks, this was Galaxias Kyklos, the milky circle from which we get our word galaxy. To the naked eye, it looks like a long, thin cloud or perhaps a wisp of steam rising into the night. It has a delicate, almost fragile appearance, a spilled river of light that seems to pulse with a quiet energy. You might wonder why it looks this way, not as individual points of light, but as a continuous, milky glow. The answer lies in the sheer scale of our home. When you look at that ribbon, you are looking at the collective light of billions of suns. They are so incredibly far away and so densely packed from our perspective that our eyes cannot distinguish one from the other. Instead, their light merges together, creating a luminous mist that has guided travelers and dreamers for thousands of years. We see this specific band of light because of where we are positioned. Our galaxy is shaped like a vast, thin disk with a slight bulge in the center, much like a spinning plate or a gentle whirlpool. Our own solar system is nestled within this disk about halfway out from the center. When we look up at the Milky Way, we are looking edge-on into the thickest part of that disk. We are peering through the very heart of the forest, seeing the combined glow of all the trees that surround us. It is a humbling perspective, a reminder that we are not observers standing on the outside looking in, but residents living deep within a magnificent, rotating structure of light and shadow. As we float here in the stillness, watching this silver river, it's hard to grasp just how large this structure really is. We see it as a ribbon, but that ribbon represents a distance so vast it defies ordinary measurement. We are beginning to move beyond the visual beauty and into the staggering physical dimensions of our galactic home, a place where the rules of distance change entirely. To truly understand the Milky Way, we must step beyond the limits of our everyday measurements and enter a realm where numbers become a form of quiet poetry. We often think of our world as large, but compared to the galaxy, even the entire solar system is like a single drop of water in a vast, silent ocean. Imagine, for a moment, the galaxy as a grand, shimmering disk of light. If we were to attempt a journey from one edge to the very opposite side, we would have to cross a distance of roughly 100,000 to 150,000 light years. It is a staggering thought, but let us pause on that term, the light year. It is a phrase that sounds like a measure of time, perhaps a very long year, but in the language of the stars, it is actually a measure of distance. It is the distance that a single beam of light, the fastest, most constant thing we know, travels through the vacuum of space in one Earth year. To put that in perspective, light travels at about 186,000 miles every single second. In the time it takes for you to blink, a beam of light could have circled our entire planet 7 times. Yet, even at this unimaginable speed, light must travel for 6 trillion miles just to complete 1 light year. 6 trillion is a number so vast it feels almost abstract, a 6 followed by 12 quiet zeros, and our galaxy is at least 100,000 of those light years across. If you were to shine a flashlight from one edge of the Milky Way today, that light would not reach the other side for another 1,000 centuries. It is a scale that reminds us how much room there is in the universe for stillness and for peace. As you lie here, listening to the skate rhythm of your breath, let the magnitude of these distances settle over you like a heavy, warm blanket. It might seem overwhelming at first, but there is a profound sense of security in this scale. These vast stretches of space are the architecture of our home. They provide the room for stars to breathe, for planets to orbit, and for the quiet stillness we feel tonight. We are held safely within this enormous, rotating structure nestled in a pocket of space that is perfectly suited for us. You are not lost in this vastness. You are anchored by it. In this grand house of light, the distances act as a buffer, a gentle silence that separates one neighborhood from the next. But as large as these empty spaces are, they are far from lonely. The sheer volume of the galaxy is filled with a population so dense and diverse that it challenges our imagination. We are beginning to shift our focus now, moving from the vast, invisible boundaries of the galaxy's diameter to the brilliant, crowded heart of its contents. Within these 100,000 light years of space, there is a community of suns so numerous they are like the very grains of the cosmos, each one a story waiting to be told. If we were to try and count every individual star within this great spiral, we would find ourselves faced with a number so large it feels almost like a dream. Scientists estimate there are between 100 billion and 400 billion stars in the Milky Way alone. It is a figure that is difficult for the human mind to truly grasp, so perhaps it is easier to imagine it through something we can touch. Think for a moment of a single beach, perhaps one you visited as a child, where the sand felt warm beneath your feet and the waves made a so rhythmic sound against the shore. If you were to pick up a single handful of that sand, you might hold 10,000 tiny grains. To reach the number of stars in our galaxy, you would need to imagine every beach on our entire planet, every coastline, every desert dune, and then count every single grain of sand upon them. That is the population of our celestial home. Each grain is a sun, and each sun is a world of its own. You might wonder why, with so many billions of suns, the night sky still holds so much darkness between the pinpricks of light. It is a gentle mystery of the cosmos. The galaxy is filled with a soft interstellar dust, tiny particles of carbon and silicates that drift between the stars like a translucent veil. This dust acts as a cosmic curtain, catching the light of distant suns and softening it, hiding the vast majority of our galactic neighbors from our naked eyes. Without this dust, the night sky would not be black. It would be a solid, glowing wall of light, so bright that we could never see the deep, restful velvet of the void. This dust provides us with the darkness we need to rest, acting as a quiet buffer that keeps the overwhelming brilliance of the galaxy at a peaceful distance. And of these billions of stars, very few are as large or as bright as the ones we see in our constellations. The vast majority of the stars in the Milky Way are much smaller and cooler than our own sun. They are called red dwarfs, steady, humble lanterns that burn with a soft amber glow. They do not blaze with a fierce heat. Instead, they simmer slowly, like the glowing embers of a hearth fire that lasts for trillions of years. They are the quiet majority, outnumbering all other types of stars combined. Together, they create a gentle, pervasive radiance that fills the disk of the galaxy, a warmth that exists even in the furthest reaches of space. As you settle deeper into your pillow, imagine this immense cloud of light, this collection of billions of steady lanterns, all rotating together in a slow, grand circle. We are now going to leave our quiet local neighborhood behind and travel toward the center of this great rotation. We are zooming in past the curtains of dust and the drifting red dwarfs, moving toward the very heart of the galaxy, where the light begins to grow more concentrated and the stars begin to huddle together in a brilliant, ancient embrace. In that direction, toward the constellation of Sagittarius, lies the glowing core that anchors everything we have seen. Imagine, as you drift further into relaxation, that we are traveling inward toward the very heart of the Milky Way. If you look up at the night sky from Earth during a clear, crisp night, you might find the constellation of Sagittarius. In that direction, hidden deep behind those thick velvet curtains of cosmic dust we spoke of, lies the galactic center. It is the glowing core of our entire galaxy, a place of incredible beauty and ancient storied light. As we approach this region, we encounter the galactic bulge. This is a vast, rounded structure at the center of the spiral, appearing like a brilliant golden red ember in the dark. The stars here are different from those in the outer arms. They are older, more mature and settled. They glow with soft hues of amber, saffron, and deep gold, having burned steadily for many billions of years. This bulge is like the warm, glowing hearth of a great house, where the oldest and most stable lights gather to keep the galaxy's heart beating. In our quiet neighborhood, the stars are like lonely ships on a vast, dark ocean. Our nearest neighbor, Proxima Centauri, is over 4 light years away, a distance so immense it takes light itself 4 years to travel between us. But here, in the crowded heart of the galactic bulge, the stars are much more social. They huddle together in a dense, luminous cloud drawn close by the strength of gravity. In the very center of this bulge, the distance between stars is measured not in years, but in mere light weeks. Imagine a neighboring sun being so close that its light reaches you in just a few days or weeks rather than years. If you were to stand on a quiet planet circling a star in this crowded center, your night sky would be unrecognizable. There would be no true deep darkness as we know it. Instead of a few thousand stars scattered across a black canvas, you would see hundreds of thousands of brilliant, colorful suns, many of them appearing as bright as the full moon in our own sky. The heavens would be a constant, shimmering twilight, a soft and golden radiance that never truly fades into the deep black of night. It is a place of perpetual evening where the sky is always filled with a comforting, warm glow, and the stars are so numerous they seem to touch one another. This dense city of stars is not just a random gathering of light. Every star, every cloud of gas, and every drifting speck of dust in this bulge is moving in a grand, coordinated dance. They are all swirling around a single, invisible point, a powerful gravitational anchor that holds the entire galaxy in its grip. Even though we cannot see this anchor with our eyes, we can observe its influence in the way the stars move, orbiting with a rhythmic, celestial precision that has lasted for eons. This silent, heavy presence is the foundation upon which our entire galactic home is built. a quiet guardian at the center of the world, keeping the great spiral of the Milky Way from drifting apart into the endless void. At the very heart of this golden city of stars, tucked away behind the dense clouds of gas and the shimmering light of the bulge, lies something truly remarkable. It is a presence both quiet and immense, known to astronomers as Sagittarius A star. While its name may sound technical, you can think of it as the great silent anchor of our galaxy. It is a supermassive black hole, but in the gentle context of the cosmos, it acts less like a void and more like a steadying weight that keeps the entire Milky Way organized and whole. Imagine a spinning top or a dancer pirouetting in the dark. For that motion to be stable, there must be a center, a point around which everything else balances. Sagittarius A star is that point for us. It is incredibly heavy, possessing the mass of 4 million of our suns combined. Yet, despite this staggering weight, it occupies a relatively small space in the grand scale of the galaxy, roughly the size of the orbit of Mercury. It is a concentrated well of gravity, so powerful that it serves as the foundation for the billions of stars that call the Milky Way home. As you lie there, drifting deeper into relaxation, imagine the stars nearest to this center. They are not falling in. Instead, they are engaged in a beautiful, rhythmic dance. They move in long, elegant loops, orbiting this invisible anchor with the precision of a cosmic clock. Some of these stars have been tracked for decades by our telescopes, their paths tracing perfect ellipses through the dark. This motion is slow, steady, and entirely predictable. It is a reminder that even in the vastness of space, there is a profound sense of order. Everything is exactly where it needs to be, held in a gentle, gravitational embrace that has lasted for billions of years and will continue for billions more. Take a slow, deep breath and feel the weight of your own body resting comfortably, just as the galaxy rests upon its silent center. There is no chaos here, only the soft, persistent pull of gravity, keeping the great spiral in its place. We are safe in this structure, part of a system that knows how to hold on to itself. As we begin to move our focus away from this singular, powerful point, we notice that the stars of the bulge don't just form a simple circle. Instead, they stretch outward in a long, glowing line, like a bridge made of light. This is the central bar of the Milky Way, a vast structure of stars and gas that connects the crowded heart of the galaxy to the wide, sweeping arms that reach out into the deep. This bar is the next stage of our journey, a luminous pathway that guides the flow of the galaxy's energy from the center toward the outer edges where we reside. This bridge of light tells us something very important about our home. If you were to look down at the Milky Way from a great height, far above the plane of its stars, you would see that it isn't a simple, perfect circle. It isn't a uniform whirlpool of light. Instead, our galaxy has a distinct and elegant shape known as a barred spiral. Imagine this long, glowing bar of stars passing right through the center, like a sturdy, luminous beam that holds the entire structure together. This central bar is a magnificent structure, stretching nearly 27,000 light years from end to end. It is composed of millions upon millions of stars, many of them older, glowing with a soft, warm orange, and red hue. These stars have been traveling these paths for billions of years, moving in synchronized harmony. As you imagine this vast bridge, feel the steadiness of it. It is a solid foundation in the middle of the swirling cosmic sea, providing a sense of structure and balance to the billions of worlds that surround it. But this bar is more than just a beautiful feature. It has a very important role to play in the life of the galaxy. Because of its immense gravity and the way it rotates, the bar acts like a cosmic funnel. It gently reaches out into the depths of space and pulls in vast clouds of hydrogen gas and interstellar dust from the outer reaches. As this material is drawn inward along the length of the bar, it begins to gather and compress, flowing toward the center like water in a slow-moving stream. This process is the secret to the galaxy's longevity. These gathering clouds of gas become nurseries, quiet, dark places where the next generation of stars is waiting to be born. In this way, the Milky Way is constantly refreshing itself. It is a dynamic, alive system, a master of recycling that takes the ancient remnants of the past and uses them to create new light. It is a slow, rhythmic cycle of birth and renewal that has been playing out for eons, a silent heartbeat that keeps the galaxy glowing. Take a slow, deep breath and imagine this gentle movement. The galaxy isn't just sitting still in the dark. It is breathing, pulling in the mist of the universe and turning it into suns. There is something deeply comforting about this constant, quiet activity. It reminds us that we are part of a system that is always moving forward, always creating, and always finding a way to sustain itself. You are safe within this rhythm, drifting along with the flow of cosmic time. As we move further along this starry bridge, we eventually reach its outer tips. This is where the straight lines of the bar begin to curve and soften. We are standing at the threshold of the spiral arms, the majestic highways of light that define the Milky Way's iconic silhouette. We are about to step off the bridge and enter the first of these massive structures, a place where the stars are packed a little tighter and the gas clouds are even richer. We are moving into the Scutum Centaurus arm, a vast and crowded neighborhood of light that serves as one of the primary anchors of our galactic home. As we step off the end of the central bar, we find ourselves merging into the Scutum Centaurus arm. This is one of the two primary major arms of our galaxy, a massive massive curving highway of light that wraps itself around the galactic center like a protective embrace. If you could see the Milky Way from far above, this arm would stand out as one of the brightest, most defined features of the entire spiral. It is a dense, crowded neighborhood filled with a rich concentration of both ancient stars and the raw materials for new ones. In this part of the galaxy, the stars are packed together more tightly than they are in the quiet space we call home. Many of these stars are long-lived and steady, having burned with a soft, reliable glow for billions of years. They move together in a grand, slow-motion parade following the curve of the arm. Interspersed among these billions of suns are vast, billowing clouds of gas and dust. These clouds are thick and heavy here, acting like a cosmic mist that catches the light of nearby stars, creating a soft, ethereal glow that permeates the entire region. It is one of the busiest highways in the galaxy, a primary structure that defines the shape and flow of the Milky Way. You might wonder how these magnificent arms keep their shape over such immense spans of time. It's a beautiful concept of physics known as density wave theory. To visualize this, imagine a slow-moving traffic jam on a long circular highway. The individual cars, the stars, and gas clouds are moving through the jam, entering from one side and eventually leaving from the other. But the jam itself, the area where everything is packed more closely together, stays in one place. In the same way, the spiral arms are not solid structures like the spokes of a wheel. They are waves of higher density. As stars and gas pass through these regions, they naturally slow down and bunch up, creating the bright visible arms we see. Once they move past the wave, they speed up again and head back out into the quieter, emptier spaces between the arms. Take a slow, deep breath and visualize this gentle bunching up of light. It is a rhythmic, natural process, like a wave moving across the surface of a deep, dark ocean. The stars aren't trapped. They are simply participating in a grand collective movement that gives the galaxy its beautiful form. There is a profound peace in knowing that even something as large as a galaxy follows these simple, elegant rules of nature. The Scutum Centaurus arm serves as a primary anchor, a foundation that helps hold the rest of the galaxy's structure together. It is a place of incredible skill and quiet power. But as we continue our journey, drifting further away from the bright, crowded center, we begin to cross the dark gap toward the second major arm of the Milky Way. We are leaving the dense traffic of the Scutum Centaurus and heading toward the outer reaches, where the space feels a bit cooler and the stars are spaced a little further apart. We are approaching the Perseus arm, a region of cold beauty and sparkling young clusters that marks the next chapter of our journey through the stars. As we glide across the vast, silent gap between the major arms of our galaxy, the light of the center begins to soften, becoming a warm, distant glow behind us. We are now entering the Perseus arm. This is the second of the Milky Way's two primary spiral structures, and it holds a unique place in our galactic geography. While the Scutum Centaurus arm sits closer to the crowded heart of the galaxy, the Perseus arm is located further out, even further from the center than our own home planet. Imagine the Perseus arm as a quiet, snowy forest on the edge of a great city. The air here feels thinner, the space more open. It is a region of cold, quiet beauty where the stars are not quite as tightly packed, allowing the deep blackness of the void to peek through more clearly. Yet, despite this sense of stillness, the Perseus arm is far from empty. It is a place of profound creation where the density waves are working their slow magic on the cold clouds of hydrogen gas. Because it is further out, the temperatures of the interstellar gas here can be incredibly low, creating the perfect conditions for gravity to pull that gas together into new shapes. Within this arm, we find some of the most beautiful structures in the entire galaxy, the open clusters. These are groups of young stars, sometimes numbering in the hundreds or thousands, that were all born at nearly the same time from the same massive cloud of gas and dust. Think of them as stellar nurseries that have just recently opened their doors. Because these stars are so young, they haven't had the time to drift away from one another yet. They stay close, like a family of siblings huddling together for warmth in the cold expanse of space. To the naked eye, if you were drifting through this region, these clusters would look like sparkling jewels scattered across a piece of dark, heavy velvet. They often glow with a brilliant, crisp blue light, the signature of young hot stars that have only recently begun to shine. These clusters, such as the famous double cluster in the constellation of Perseus, act as bright markers along the spiral arm, illuminating the surrounding gas and creating a scene of breathtaking serenity. Take a moment to visualize one of these clusters. See the tiny, sharp points of light, each one a sun in its infancy, nestled within a faint, ghostly mist of the leftover gas that created them. Everything here moves in slow motion. The stars orbit the galactic center in a grand, steady rhythm that takes millions of years to complete. There is no rush here, no noise, only the silent, steady pulse of light against the dark. As we linger in the cool, jewel-toned beauty of the Perseus arm, we begin to realize that the galaxy is not just one uniform shape, but a complex tapestry of major arms, minor branches, and quiet pockets of space. We have seen the great highways of the galaxy, but now it is time to return to a place that feels a little more familiar. We are moving away from the outer Perseus arm and drifting back toward the middle ground, toward a smaller, cozy branch of the spiral that we call our own. We are heading for the Orion Cygnus arm, the gentle spur of light that cradles our sun and every star you have ever seen in the night sky. We leave behind the vast icy stretches of the Perseus arm and begin to drift inward, toward a place that feels a little warmer, a little more like home. We are entering the Orion Cygnus arm. In the grand map of the Milky Way, this region is often called a minor arm, or sometimes just a spur. If the major spiral arms are the great, roaring highways of the galaxy, the Orion Cygnus arm is a quiet, sun-dappled side street. It is a cozy pocket of steers and gas, a bridge that spans the gap between the inner and outer reaches of the spiral. Though it may be smaller than the giants we've just passed, for us, it is the most significant place in the entire cosmos. Every star you have ever seen with your naked eye from your backyard or a dark hilltop, every constellation that has guided travelers for thousands of years, exists within this local neighborhood. It is named, quite fittingly, after the constellation Orion. When you look up on a crisp winter night and see the three bright stars of the Hunter's Belt, you are looking at the very heart of our galactic home. These stars are our immediate neighbors, traveling through the void alongside us in a slow, graceful formation. The Orion Cygnus arm is roughly 3,500 light-years wide and about 10,000 light-years long, a relatively small but densely packed stream of celestial beauty. Take a slow, deep breath now and let your mind settle into this realization. Right at this very moment, as you lie in the comfort and safety of your bed, you are sailing. You are a passenger on a small blue planet, currently drifting through the Orion Cygnus arm at over 500,000 miles per hour. Yet, because the scale of the galaxy is so immense and the laws of physics so constant, this incredible journey feels like perfect stillness. You are being carried along by a celestial current, cradled within a stream of stars that stretches for thousands of light years in either direction. There is no turbulence here, only the steady, rhythmic pulse of the universe. Imagine the stars outside your window not as distant points, but as fellow travelers on this long, quiet voyage through the night. As we glide through this local neighborhood, the darkness between the stars begins to feel less like a vacuum and more like a soft, protective blanket. We are not alone in this arm. We are surrounded by an incredible variety of suns, each with its own story to tell. To understand the beauty of our home, we must look closer at the individuals that make up this crowd of light. We begin to shift our focus from the broad where of our location to the what. The different types of stars that populate this cozy corner of the galaxy. Some are giants, some are like our own sun, but the most common among them are the ones we rarely see, the quiet, enduring lanterns that outnumber all the others combined. Let us move deeper into the crowd to meet the most common residents of our galactic street. As we drift through this local arm of the galaxy, you might imagine the sky is filled mostly with brilliant, blazing suns like our own. But the truth is much quieter and perhaps even more comforting. The most common residents of our galactic neighborhood, and indeed the entire Milky Way, are stars that the naked eye can never see from Earth. These are the red dwarfs. Imagine a star that is smaller and cooler than our sun, glowing with a soft, deep crimson light. If our sun were a roaring bonfire, a red dwarf would be the glowing embers at the end of the night, steady, warm, and incredibly enduring. Because they are smaller and have less mass, they don't burn through their nuclear fuel in a frantic rush. Instead, they sip their hydrogen slowly, pacing themselves with a cum that stretches across unimaginable spans of time. They are the masters of patience in a universe that often feels defined by its vast changes. In the grand timeline of the universe, our own sun is considered middle-aged, having lived for about 5 billion years, with perhaps another 5 billion to go before it changes its form. But a red dwarf operates on a scale that humbles even the oldest galaxies. These tiny stars are so efficient that the smallest among them can continue to glow for trillions of years. To put that in perspective, the entire universe is only about 13.8 billion years old. This means that every red dwarf ever born since the beginning of time is still shining today. Not a single one has ever reached the end of its life. They will continue to flicker softly long after every other type of star has faded into the dark. They are the ultimate survivors, the quiet, permanent witnesses to the story of the cosmos. Think of them as the steady lanterns of the galaxy. They don't flicker with instability. They don't end their lives in violent explosions, and they don't demand attention with blinding brightness. They simply exist, providing a constant, low-level warmth to the planets that may be tucked closely around them. In our galaxy alone, it is estimated that at least 75% of all stars are red dwarfs. They outnumber the bright giants and the medium-sized suns by an incredible margin, forming a vast hidden network of light that populates the spaces between the stars we recognize. Even though they are the most numerous, they remain a secret to the casual observer. Even Proxima Centauri, the very closest star to our own solar system, is a red dwarf. Yet it is so faint that it cannot be seen without the help of a telescope. There is something deeply peaceful about the deity that the universe is mostly populated by these gentle, long-lived stars. Small points of light that ask for nothing and provide a potential home for worlds that might enjoy billions of years of uninterrupted stability. As you settle deeper into the warmth of your blankets, let the thought of these trillions of years of steady light settle your mind. The universe isn't just a place of high-energy events. It is, at its heart, a place of quiet, enduring persistence. But while these tiny red suns are the most common, they are not the stars we are most familiar with. To understand our own unique place in this river of light, we must turn our attention to a star that is slightly rarer, slightly brighter, and much closer to our hearts. The star that defines our days, our years, and our very existence. We move now from the dim red glow of the dwarfs to the steady, familiar presence of a star like our own sun. Imagine for a moment the light of our own sun. In the quiet of your room, it might seem like a distant concept, but it is the star that defines every rhythm of our lives. Astronomers call stars like ours yellow dwarfs, or more formally, G-type main sequence stars. It's a humble name for something so magnificent, yet it captures the essence of a star that is perfectly balanced for the existence of life. It is a soothing thought to realize that while we often imagine the sun as a golden or orange orb, its true nature is even more serene. If you were to stand in the stillness of open space, looking back at our star from the velvet dark, you wouldn't see a yellow ball. You would see a sphere of pure, brilliant white. The golden color we see from our beds or through our windows is a gentle trick played by our atmosphere. As sunlight enters our air, the shorter blue wavelengths are scattered away, giving us the beautiful blue of our daytime sky, while the remaining light reaches our eyes with that familiar, warm, golden hue. In the vacuum of the cosmos, however, our sun is a steady white beacon, shining with a light that contains every color of the rainbow perfectly balanced together. In the grand map of the Milky Way, stars like our sun are quite special. They aren't the most common. As we've learned, the red dwarfs hold that title by a vast margin. But they aren't the rarest either. Only about 7% of the stars in our galaxy belong to this G-type family. This means that if you were to count 100 stars at random during a journey across the galaxy, only 7 of them would feel like the sun we know. This small percentage makes our solar system a part of an exclusive and significant family of suns, scattered like rare coins throughout the river of stars. These stars are often described as being in the Goldilocks category of stellar evolution. They are large enough to provide a vast amount of energy, yet small enough to live for billions of years without exhausting their fuel too quickly. Our sun is currently in the middle of its long, stable life. It has been shining steadily for 4.5 billion years, and it has enough hydrogen to continue for another 5 billion. This incredible stability is what allowed the Earth to settle, for oceans to form, and for the slow, patient story of life to unfold. As you breathe in and out, feel the comfort in that cosmic reliability. Our star doesn't rush. It doesn't flicker or flare with the instability seen in many other types of stars. It is a constant rhythmic presence that has watched over our world since its very beginning, providing the steady warmth that allows us to sleep soundly tonight. But as we drift further away from our local neighborhood and deeper into the glowing spiral arms of the Milky Way, the scenery begins to change. The steady white light of stars like our sun begins to be outshone by something much more intense and much more fleeting. We are moving toward the rare, dramatic giants of the galaxy, stars that burn with a fierce sapphire light and hold a power that is almost difficult to comprehend. These are the blue giants, the brilliant beacons that light up the darkest corners of the spiral arms, living lives that are as dazzling as they are brief. Imagine, as we travel deeper into the spiral arms, the steady golden glow of stars like our sun beginning to fade into the background. In its place, a new kind of light emerges, one that is sharp, electric, and breathtakingly blue. These are the blue giants, the rarest and most brilliant beacons in the entire Milky Way. While our sun is a gentle hearth, these stars are the cosmic furnaces of the galaxy. They are incredibly hot, with surface temperatures reaching over 30,000 degrees Celsius, many times hotter than the sun. This intense heat gives them their distinct sapphire color, a light so powerful that it can illuminate entire clouds of gas and dust from light years away. When you see a photograph of a nebula glowing with vibrant pinks and purples, it is often one of these blue giants nearby acting like a floodlight in the dark, revealing the hidden textures of the interstellar medium. There is a poetic trade-off for such magnificence, however. In the universe, the brighter a star shines, the faster it consumes its fuel. If our sun is like a long-burning, steady candle that can last for 10 billion years, a blue giant is like a brilliant firework. Because they are so massive, often 10, 20, or even 50 times the mass of our sun, the pressure at their cores is immense. They burn through their hydrogen at a staggering rate, living fast lives that last only a few million years. In the grand timeline of the galaxy, a few million years is but a blink of an eye. They are born, they light up the spiral arms with their fierce beauty, and then they prepare for a dramatic transformation. This transformation is what astronomers call a supernova. While the word might sound intense, in the quiet context of the cosmos, it is a moment of profound creation. When a blue giant can no longer support its own weight, it collapses and then rebounds in a spectacular release of energy. This is the moment when the universe creates the heavy elements that make life possible. The calcium in your bones, the iron in your blood, and even the gold in a wedding ring were all forged in the heart of a dying giant or during the intense heat of its final flash. These stars are the galaxy's ultimate providers, scattering the building blocks of future planets and future people across the void. They give their lives so that the rest of the galaxy can have the materials it needs to flourish. As the brilliant flash of the supernova eventually fades, the heavy elements it created drift away to become part of new stars and new worlds. But the story of the star itself doesn't always end in total disappearance. Something remains in the center of that vast, expanding cloud of stardust. Sometimes the core is crushed into something small, dense, and incredibly quiet. As the echoes of the giant's life settle into a deep cosmic stillness, we find ourselves looking at the remnants, the silent, glowing embers that represent the next chapter of our journey. We are moving now toward the quiet aftermath, where the ghosts of stars reside in the form of white dwarfs, cooling slowly in the velvet dark. After the grand, luminous display of a star's life and its eventual transition, we find ourselves in a place of profound, quiet aftermath. Here, in the soft, dark pockets of the Milky Way, we encounter the white dwarf. It is a celestial object that embodies the idea of stillness and endurance. Imagine, if you will, a star that has spent billions of years shining brightly, and then, in a final act of grace, gently sheds its outer layers into space, like a tree losing its leaves in the late autumn. What is left behind is the star's very heart, a glowing, concentrated core that has no more fuel to burn, but possesses an incredible amount of stored warmth. This core is remarkably small, roughly the size of our own Earth. It is strange to think of something so compact holding the legacy of a giant sun, but that is the nature of these stellar remnants. Because so much matter is packed into such a tiny space, the density of a white dwarf is staggering. To give you a sense of this weight, imagine holding a small silver teaspoon in your hand. If you were to fill that spoon with the material from a white dwarf, that single teaspoon would weigh as much as a 5-ton elephant. It is a heavy, solid thing, yet it floats weightlessly in the vacuum of space, a silent, glowing anchor in the galactic sea. As you lie there, comfortable and still, consider the incredible patience of these stars. A white dwarf does not struggle. It does not roar with nuclear fire. It simply exists, radiating its leftover heat into the darkness. Because Bas is such an effective insulator, it takes a very, very long time for a white dwarf to cool down. We are talking about time scales that stretch far beyond the current age of the universe. For billions of years, these embers will continue to glow, slowly fading from a brilliant diamond white to a soft, buttery yellow, and eventually to a dim, tired red. In the unimaginably distant future, a white dwarf will finally lose the last of its warmth. It will become what astronomers call a black dwarf, a cold, dark sphere of crystallized carbon and oxygen drifting invisibly through the galaxy. There are no black dwarfs in our universe yet, because the universe is still too young for any star to have finished cooling down. Every white dwarf that has ever been created is still out there right now, glowing softly, keeping its vigil in the dark. They are the ghosts of the past, reminding us that even after the fire goes out, something beautiful and solid remains. The white dwarf is a story of a life lived to its fullest, ending in a peaceful, cooling rest. But as we move deeper into the gaps between the bright constellations, we find another kind of inhabitant, one that never had a chance to shine at all. These are the objects that sit in the twilight between planets and stars, the ones that gathered in the dark, but never quite found the spark to ignite their own light. We are drifting now toward these quiet, hidden travelers, the stars that never truly turned on. In the vast velvet stretches of the Milky Way, there exists a unique class of celestial bodies that live in a perpetual twilight. These are the brown dwarfs, often called failed stars by astronomers, though that name feels perhaps a bit too harsh for such quiet, mysterious travelers. They are the bridge between the largest of planets and the smallest of stars, caught in a state of being that is neither one nor the other. Imagine a world much larger than Jupiter, perhaps 13 to 80 times more massive, yet still too small to ignite the nuclear fire that makes a true star shine. They gathered the ingredients for a sun, pulling in gas and dust with the hope of brilliance, but they simply could not reach the internal pressure and temperature needed to fuse hydrogen. They are the stars that never quite woke up, remaining in a state of peaceful, eternal slumber. Because they lack the internal engine of a true star, brown dwarfs do not emit the bright, visible light we see in the night sky. To our eyes, if we were to pass one in a ship, they would appear as dark mahogany-colored spheres, almost invisible against the blackness of space. However, they are not truly cold. They hold on to the heat of their initial creation, glowing softly in the infrared spectrum. If you had eyes that could see heat, the galaxy would suddenly be populated by thousands upon thousands of these warm, glowing embers. They are like the coals in a hearth that have stopped flaming but still radiate a gentle, lingering warmth into the room. Some brown dwarfs even have complex atmospheres with clouds and weather, much like the gas giants in our own solar system, but on a much grander, hotter scale. They may have rain made of molten iron or silicate dust, falling silently through their thick, swirling clouds, far away from any observer. As you settle deeper into your pillow, take a moment to imagine one of these brown dwarfs drifting through the immense dark gaps between the stars. It is a lonely, quiet existence, far from the blinding light of the great suns, but there is a profound peace in it. These objects do not burn out, they do not explode. They simply cool very slowly over billions of years, moving through the galaxy like a dark ship on a calm midnight sea. They remind us that the universe is not just made of the things that shine the brightest, but also of the quiet, hidden things that exist just out of sight. You are safe here in the quiet, much like these gentle travelers, held in the soft gravity of the galaxy's embrace, drifting through the stillness. But even as we look at these individual stars and dwarfs, we realize they are not alone in a total vacuum. The spaces between them, which look so empty and black, are actually filled with something very subtle and very ancient. As we leave the brown dwarfs behind, we begin to notice a faint, ghostly mist beginning to shimmer in the darkness. This is the interstellar medium, the thin, delicate breath of the galaxy that connects every star to its neighbor. It is the raw material of everything we have seen so far, a quiet ocean of gas and dust waiting for the right moment to become something new. As we move into this thin cosmic mist, we begin to understand that even the empty space between the stars is alive with potential. As we drift further from the warmth of the stars, we enter the great island expanse that lies between them. To our eyes, this space might seem like a total void, a perfect empty vacuum. But if we look closely, we find that the Milky Way is never truly empty. It is filled with a very thin, very delicate mist known as the interstellar medium. This is the galaxy's breath, quiet ocean of gas and dust that flows between the suns, connecting the distant points of light like a soft, invisible web. It is the raw material from which everything we have seen, the giants, the dwarfs, and the planets, was originally fashioned. This cosmic mist is made almost entirely of the two simplest elements in the universe, hydrogen and helium. These are the ancient building blocks of the stars themselves, left over from the very beginning of time. Imagine a fog so thin that it is almost beyond our ability to perceive. It is not like the thick, heavy clouds we see on a misty morning on Earth, which cling to the ground and obscure our vision. Instead, it is a ghostly, transparent presence, stretching for trillions of miles in every direction. It is the quiet background of the galaxy, a silent witness to the passage of billions of years. In this space, there is no wind to blow the mist away, only the slow, rhythmic pull of gravity and the gentle pressure of starlight. To understand just how thin this medium is, imagine a small cube, about the size of a sugar cube, 1 cubic centimeter. On Earth, at sea level, that tiny space would contain billions upon billions of air molecules, constantly colliding and interacting. But out here, in the deep reaches of the interstellar medium, that same cubic centimeter might contain only a single atom. It is a vacuum more perfect than anything we can create in a laboratory. It is so sparse that a single particle might travel for light years without ever bumping into another companion. This creates a sense of profound stillness, a level of quiet that is impossible to find anywhere else. You are moving through a space so empty that it feels like a physical manifestation of peace. Yet, because the galaxy is so unimaginably vast, this nothingness begins to add up in a way that is hard to fathom. When you look across the entire 100,000 light-year span of the Milky Way, this thin, lonely mist actually accounts for a significant portion of the galaxy's mass. Even though it is mostly empty space, the sheer, staggering volume of it means that the interstellar medium contains the mass of billions of suns. It is a massive, sleeping giant, spread out so thinly that it feels like a dream, yet it holds the potential to create entire generations of new stars. It is the reservoir of the galaxy, a vast storehouse of energy waiting for the right moment to awaken. As you breathe in slowly and feel the weight of your own body resting securely, imagine this thin, cool mist surrounding us. It is not a cold or hostile void, but a cradle. It is the substance that connects us to the furthest reaches of the spiral arms. As we continue our journey through this quiet cosmic ocean, we notice that the mist is not perfectly uniform. In some places, it begins to gather and swirl, like steam on a window or a soft cloud forming in a summer sky. The gas and dust start to huddle together, drawn by their own tiny collective gravity. These regions become denser and more colorful, transforming from a faint, invisible mist into the majestic, glowing structures we call nebulae. These are the gardens of the galaxy, the places where the thin breath of the interstellar medium finally begins to thicken and glow with the promise of new life. As we drift toward one of the most famous of these gardens, the darkness begins to give way to a soft, ethereal light, painting the void with colors you have only seen in your dream. As we drift further into the heart of these gathering mists, we encounter one of the most magnificent sights in the entire night sky, the Orion Nebula. Even from our home on Earth, this nebula is so large and so bright that you can see it with your own eyes on a clear winter night, appearing as a soft, fuzzy stir in the sword of the constellation Orion. But as we draw closer in our quiet journey, that fuzzy light expands into a breathtaking tapestry of color. It is a vast, glowing cavern of gas spanning 24 light years across, a distance so great that if you were to travel across it at the speed of a jet plane, it would take you millions of years just to reach the other side. The colors here are soft and ethereal, painting the darkness with shades of rose pink, delicate greens, and deep velvet blues. These colors are not just beautiful to look at, they are the signature of the elements themselves. The pinkish hues come from vast clouds of hydrogen, the most abundant element in the universe, glowing as it is energized by the intense light of newborn stars. The hints of green and blue are the breath of oxygen and other gases, reacting to the cosmic energy surrounding them. It feels like standing inside a giant living opal where the light is soft, diffused, and perfectly calm. Deep within these colorful folds of gas, something incredible is happening. Gravity, that patient and invisible force, is busy at work. It reaches into the thinnest parts of the cloud and begins to pull the gas and dust together, tighter and tighter. These pockets of matter become denser, warmer, and more compact, forming what astronomers call protostars. Imagine these as glowing cocoons of light. Tucked away inside the dark blankets of the nebula, they are stars that haven't quite turned on yet. They are still gathering their strength, still growing, protected by the very dust that created them. There are hundreds of these little cocoons scattered throughout the Orion Nebula, each one a promise of a new sun that will one day shine across the galaxy. It is a humbling thought to realize that this cycle of birth is happening right now, in the quiet depths of the night. While you lie here, resting and breathing slowly, these cosmic nurseries are tirelessly producing the next generation of light. The universe does not hurry. It moves with a slow, rhythmic grace, turning dust into stars over millions of years. This process is steady, reliable, and profoundly peaceful. It is the heartbeat of the galaxy, a reminder that even in the dark, there is always something new being formed. As we leave the warm pink glow of Orion behind, we find that the galaxy has many more of these magnificent structures to show us. Some are shaped like delicate bubbles, others like wispy veils, and some stand like ancient monumental towers against the stars. We are drifting now toward a place where the clouds of gas are so tall and so majestic that they have earned the name the Pillars of Creation. These towering structures, located in the Eagle Nebula, stand as silent sentinels in the dark. And as we approach them, we begin to see the true scale of the galaxy's artistry. Imagine standing before three immense, towering columns of gas and dust, rising out of the dark like the foundations of an ancient cathedral. These are the Pillars of Creation, located deep within the Eagle Nebula, about 7,000 light years away from the quiet comfort of your room. Though they look like solid stone in the famous images we see, they are actually made of cold, ghostly hydrogen and microscopic dust. They are so incredibly tall that if you were to travel from the bottom of the largest pillar to its top, it would take you several years, even if you were traveling at the speed of light. Each pillar is a majestic monument to the sheer scale of the Milky Way, a place where the very fabric of the galaxy is being shaped into something new. As you watch these pillars in your mind's eye, notice how their edges seem to glow with a soft, ethereal light. This isn't just a random shimmer. It is the result of a powerful cosmic wind. Nearby, just outside the frame of these pillars, a cluster of massive hot stars has recently been born. These stars are young and energetic, and they pour out intense ultraviolet radiation and streams of charged particles. This stellar wind acts like a sculptor's chisel, slowly but surely carving away the edges of the pillars. It is a process that happens with incredible patience, a slow erosion that takes thousands of years to notice. The gas is being pushed and evaporated, creating those jagged, finger-like shapes that reach out into the void. Take a slow, deep breath and let yourself feel the stillness of this process. Even though we use words like wind and erosion, there is no sound in this part of the galaxy. It is a silent, graceful transformation. The pillars are being destroyed by the very light they helped create, yet in that destruction, they are giving birth. Inside those thick, dark clouds, gravity is pulling material together to form new suns. It is a beautiful, bittersweet cycle. The old clouds fading away to make room for the new light. You can visualize the tips of these pillars as nurseries, where the next generation of stars is being cradled in the cold, dark mist. Over thousands of years, these pillars will eventually vanish, spreading their gas back into the interstellar medium to be used again somewhere else in the galaxy's long history. But for now, they stand tall and resolute, a testament to the creative power of the universe. And as these new stars begin to shine within the pillars, something else is happening, something even smaller and more intricate. Around these infant suns, the leftover dust and gas aren't just drifting away. They are beginning to swirl and clump together, forming the beginnings of something solid. Just as the galaxy creates stars, it also creates the stages upon which life might one day walk. We are moving now from the grand towering clouds of the nebula to the smaller hidden worlds that emerge from them, the planets that circle other suns in the dark. As the dust and gas from those towering nebula begin to settle around a newborn star, they don't simply drift away into the void. Instead, gravity continues its quiet, persistent work, pulling the leftover fragments together into spinning disks. For a long time, as we looked up at the night sky, we could only wonder if our own solar system was a rare jewel, a solitary family of planets in a galaxy of lonely suns. But in recent years, that mystery has been replaced by a beautiful, gentle realization. We now know that the dark spaces between the stars are teeming with hidden worlds. These are the exoplanets, planets that orbit a sun other than our own, each one a unique destination in the vastness of the Milky Way. Take a slow, quiet breath and imagine the sheer scale of this discovery. Every star you have ever seen in the night sky, from the brightest beacon to the faintest glimmer, likely hosts at least one planet. Many of them host entire systems, families of worlds, circling their parent stars in a rhythmic celestial dance. When you look at the river of milk stretching across the heavens, you aren't just looking at points of light. You are looking at trillions of horizons, trillions of landscapes that have never been touched by human feet. The numbers are truly staggering, yet they carry a sense of peace rather than overwhelm. In the short time we have been looking, we have confirmed the existence of over 5,000 exoplanets. But this is just the beginning, a tiny sample from our immediate neighborhood. Astronomers now estimate that there are likely more planets in the Milky Way than there are stars. In a galaxy of hundreds of billions of suns, there are trillions of worlds, each one spinning silently in its own corner of the spiral arms. This realization transforms the way we see our galactic home. The Milky Way is no longer just a collection of burning gas and nuclear fusion. It is a galaxy of worlds. It is a vast, silent archive of mountains, atmospheres, and plains. For every star that illuminates the dark, there are worlds waiting in the glow, experiencing their own sunsets and their own long, cold nights. Some of these planets are massive and gaseous, while others are small and rocky, much like the ground beneath your bed. They are out there right now, drifting through the velvet blackness, held in the steady, invisible grip of gravity. As we begin to peer more closely into these distant systems, we find that the diversity of these worlds is far greater than anything we could have imagined. Our own solar system, with its familiar mix of rocky inner planets and gaseous giants, is just one possible arrangement. Out in the deeper reaches of the galaxy, there are planets that challenge our understanding of nature itself. There are worlds that are strange and beautiful, existing in conditions that seem like something out of a dream. We are moving now toward these specific, remarkable places, the giants that loom large in the dark, and the strange weather that defines their silent existence. Among the most striking of these distant worlds are the giants, planets so massive they dwarf our own Earth many times over. In the early days of hunting for exoplanets, we discovered a class of worlds that challenged everything we thought we knew about how solar systems are built. These are the hot Jupiters. Imagine a planet as large as the greatest gas giant in our own system, but instead of sitting in the cold outer reaches of space, it orbits its star so closely that a single year lasts only a few days. These planets are so near to their suns that they are bloated by the intense heat, their atmospheres expanding like a slow, glowing breath. Visualize these giants for a moment. They are not solid like the ground beneath you. They are vast, swirling spheres of gas and liquid, held together by an immense, quiescent gravity. Their clouds are not made of water vapor like the ones that drift past your window, but of exotic minerals and metals. On some of these worlds, the heat is so great that iron might turn to mist, entering into the upper atmosphere before cooling and falling back down as a metallic morning dew. The physics of these places creates a type of beauty that is difficult to fathom. In the deep, heavy layers of some gas giants, the pressure is so intense that it can transform common elements into precious things. Scientists believe that on certain planets, it may literally rain diamonds. Deep within the atmosphere, carbon atoms are squeezed with such steady rhythmic force that they crystallize, drifting downward through the dark like sparkling hailstones in a slow-motion sea of gas. On other worlds, where the clouds are made of silicates, the rain might be made of liquid glass, blown sideways by winds that never cease. Think of the sound of such a place. It is not a silence, but a deep resonant hum, the sound of 1,000-mile-per-hour wind moving through an atmosphere so thick it feels almost like water. To us, a wind that fast sounds chaotic, but on the scale of a gas giant, it is a steady, ancient song. It is a constant, low-frequency vibration that has been singing for billions of years, a white noise that fills the vast gaps between the stars. These winds carry heat from the day side to the night side in a never-ending cycle, keeping the planet in a state of eternal, rhythmic motion. As we drift past these massive, swirling beacons, we begin to look for something smaller, something perhaps a bit more familiar. While the gas giants are magnificent in their scale, there is a different kind of wonder found in the rocky worlds, the planets with solid crusts, silent mountains, and the potential for something truly special. We are turning our gaze now toward the quiet pockets of the galaxy where the conditions are just right. We are searching for the places where the light of a distant sun hits the ground with a gentle warmth, and where the air might be still enough to hold a secret. We are moving toward the rocky shores of the Goldilocks worlds, nestled safely in the dark. This special region, the Goldilocks zone, is not a physical place you can touch, but a delicate balance of distance and heat. Just as you might move closer to a fireplace to feel its warmth, or step back if the glow becomes too intense, a planet must find its perfect seat at the cosmic table. It is the region around a star where the temperature is just right, not so hot that the oceans boil away into steam, and not so cold that they freeze into eternal silent ice. In this narrow band of light, water can remain liquid, flowing gently over stones or pooling in quiet basins under the light of a distant sun. Because water is the cradle for all life, as we understand it, these zones are the most watched and studied parts of our galactic neighborhood. Think of the diversity of these zones across our galaxy. They are not one size fits all. Around a small, cool red dwarf, the Goldilocks zone is very close to the star, a tight and intimate orbit where the sun looms large and crimson in the sky, never moving from its spot. Around a bright yellow star like our sun, the zone sits much further back, bathed in a steady white radiance. Every star in the Milky Way has its own unique version of this temperate harbor, a halo of possibility where the conditions for life might just take hold. It is as if the galaxy is filled with billions of small, warm islands, separated by the vast, cold ocean of the vacuum. The scale of this possibility is staggering, yet deeply peaceful. Current scientific estimates suggest that there may be as many as 40 billion Earth-sized planets nestled within these habitable zones throughout the Milky Way. 40 billion worlds, each with its own geography, its own gravity, and its own unique rhythm of day and night. If you were to count them one by one, assigning a single second to every planet, it would take you over 1,200 years to finish the list. It is a vast, silent family of worlds most of which we will never see. Yet they exist out there in the dark, spinning in their slow, predictable circles, held by the invisible threads of gravity. Imagine for a moment standing on the surface of one of these distant shores. Perhaps the ground beneath your feet is made of dark volcanic basalt or soft wind-swept sands the color of twilight. There may be mountains that have never been climbed, their peaks dusted with exotic frosts, and valleys where the only sound is the low whistle of a breeze moving through ancient rock formations. Even if these worlds are empty of life, they are not empty of beauty. They are masterpieces of physics and time, silent landscapes waiting under the light of alien suns. You can visualize a sunset on one of these worlds, perhaps a deep, bruised purple sky, where a small orange sun sinks slowly toward a jagged horizon, casting long, still shadows across a world that has never known a footprint. These are places of absolute stillness, where the stars above are the only witnesses to the passing of ages. As you breathe in slowly, feeling the weight of your own world supporting you, it is comforting to know that the galaxy is so rich with these potential homes. They are like quiet rooms in a vast mansion, each one prepared and waiting, held in the steady gravitational grip of their parent stars. But the story of planets in our galaxy is not always one of stability and warmth. Space is a dynamic place, and sometimes the harmony of a solar system is interrupted. Not every world gets to stay in the light. Some planets, through a cosmic game of gravitational billiards, find themselves pushed away from their suns, drifting out into the deep, cold shadows between the stars. These are the nomads of the Milky Way, the worlds that have said goodbye to the day and embraced a different, much lonelier journey. Imagine a world without a sunrise, a planet that has untethered itself from the gravity of its parent star and wandered out into the deep velvet black of interstellar space. These are the nomads of the galaxy, known to astronomers as rogue planets. They are the solitary travelers of the Milky Way, moving through the darkness, far from the light of any sun. While it might sound like a lonely existence, try to visualize the profound peace in their journey. These worlds were often born in the chaotic early days of a solar system, perhaps nudged by a larger neighbor, like a Jupiter-sized giant, until they were gently cast out into the sea of stars. Now, they no longer belong to a single star. They belong to the galaxy itself. Scientists believe there may be billions, perhaps even trillions of these rogue planets drifting through the Milky Way. In fact, some recent estimates suggest there could be more rogue planets than there are stars in the sky. As you lie there, perfectly still and comfortable, imagine one of these worlds passing through the sad-quiet gaps between the constellations. It doesn't have a year because it doesn't orbit a sun. It doesn't have seasons, and it doesn't have a noon. It exists in a state of eternal starlit night, a silent sphere gliding through the void at thousands of miles per hour, yet feeling as though it is standing perfectly still. You might think such a world would be a frozen, brittle husk, but that isn't necessarily the case. Deep inside these rogue planets, the same processes that keep the center of our Earth hot are still at work. Radioactive elements in the planet's core decay over billions of years, releasing a steady, gentle warmth that radiates from the center outward. Some of these planets might even possess thick atmospheres that act like a heavy protective blanket, trapping that internal heat and keeping the surface much warmer than the freezing vacuum outside. On such a world, you might find deep liquid oceans hidden beneath a thick shell of ice, kept fluid by volcanic vents on the seafloor. In the absolute silence of the interstellar void, these planets carry their own embers of warmth, like a traveler carrying a small glowing lantern through a dark, quiet forest. Take a slow, deep breath and consider the freedom of such a world. It is unbothered by the harsh flares of a temperamental sun or the gravitational tugs of planetary siblings. It moves with a quiet, steady momentum, a graceful and solitary dance through the dark. It is a reminder that even in the vastest, emptiest spaces of our galaxy, there is structure, there is internal warmth, and there is a sense of calm. These planets are not lost. They are simply at home in the wider universe, peaceful travelers in a journey that lasts for eons. As we pull our perspective back from these solitary nomads, zooming out until the individual planets fade into the distance, we begin to see that the space between the stars is not as empty as it first appeared. Even the darkest gaps, the places where we thought there was only nothing, are filled with a delicate, ghostly substance. As we look across the great spans of the Milky Way's spiral arms, we start to notice a fine mist, a cosmic veil that softens the light of the distant galactic core and hides the stars behind it. This is the interstellar dust, a silent, vast architect of the galaxy's most mysterious shapes. And it is here, in these shadows, that the next part of our journey begins. As we look closer at this fine cosmic mist, we find that it isn't quite what we might expect. It is often called interstellar dust, but it isn't like the soft gray dust that settles on a bookshelf at home. Instead, think of it as a very fine cosmic soot. These tiny particles are the remnants of stars that lived and died long ago, scattered across the galaxy like seeds in a garden. Most of this dust is made of carbon, similar to the graphite in a pencil, and silicates, which are essentially tiny grains of panther glass. These particles are incredibly small, often smaller than a single hair's width, and they are so fine that they behave more like stomach than solid matter. Imagine a great silent cloud of smoke drifting through the vastness of the spiral arms, so thin that you could fly through it for millions of miles and never feel a thing. Yet, when we look up at the band of the Milky Way from a dark place on Earth, we see the true power of this dust. You might have noticed that the river of light in the sky isn't a solid, unbroken glow. It is filled with dark patches, long streaks of shadow that look like holes in the universe. Astronomers call one of the largest of these the Great Rift. For a long time, people thought these were empty voids where no stars existed. But we know now that the stars are still there, shining just as brightly as any others. They are simply hidden behind massive, cold clouds of this cosmic soot. Take a slow, deep breath and visualize those clouds. They are like a heavy velvet curtain pulled across a brightly lit window. They absorb and scatter the starlight, protecting the deeper parts of the galaxy from our view. It's a strange and beautiful thought. Some of the most striking features of our night sky are defined not by what we can see, but by what is being hidden. If we could somehow sweep all of this dust away, if we could clear the cosmic air and see the Milky Way in its pure, unfiltered glory, our night sky would be transformed. Without the dust to dim the light, the center of our galaxy would shine with such intensity that it would cast shadows on the ground here on Earth. The sky would be so crowded with the overlapping glow of billions of stars that you could easily sit outside in the middle of the night and read a book by the silvery light of the galaxy alone. But the dust remains a quiet protector that keeps the galaxy's secrets and creates a sense of depth and mystery. Kissed. It drifts in long, graceful filaments, held in place by forces we cannot see with our eyes. Just as the planets are held by gravity, this vast collection of dust and gas is guided by an invisible structure, a gentle, unseen web that stretches from one edge of the spiral to the other. As we move deeper into the silence of the night, we begin to feel the presence of these hidden threads, the silent forces that cradle the stars and the soot alike, keeping the entire galaxy in a state of perfect balanced harmony. As we drift further into the quiet of the galaxy, we begin to realize that the space between the stars is not truly empty. It is filled with a presence that we cannot see with our eyes, but one that guides the very shape of the spiral arms and the movement of everything within them. This is the galactic magnetic field, a silent, invisible force that permeates the entire Milky Way. Imagine a magnetic field so vast that it spans the entire 100,000 light-year diameter of our home, yet it is incredibly delicate. To understand its strength, think of the magnet on your refrigerator, or the magnetic field of the Earth that pulls a compass needle toward the north. The galactic field is 1,000,000 times weaker than those. If you were to hold a compass in the deep reaches of interstellar space, the needle wouldn't snap into place. The pull is too soft, too subtle for that. Instead, this field acts like a gentle, invisible loom weaving through the clouds of gas and the fine cosmic dust we've just explored. This magnetic field serves a vital purpose in the life of the galaxy. It acts as a guide for cosmic rays, those tiny, high-speed particles that zip through the vacuum of space at nearly the speed of light. Without this magnetic web, these particles would fly in straight, chaotic lines, scattering into the void. But the field gently curves their paths, catching them and keeping them moving in long, graceful loops through the spiral arms. It also helps to funnel the cold gas clouds, nudging the atoms closer together so they can eventually collapse under their own weight and begin the process of forming new suns. It is a quiet, persistent architect working tirelessly in the dark to maintain the structure and order of our galactic home. Take a slow, deep breath and try to visualize this for a moment. Imagine the entire Milky Way, the bright core, the sweeping arms, the dark rifts of dust, all held within a soft, glowing web of magnetic lines. These lines aren't rigid or harsh. They are flexible, moving and swaying like silk threads in a light breeze. It is a gentle, invisible structure that cradles the entire spiral, ensuring that every star and every planet stays on its destined path. You can feel the comfort in that thought, that even in the vastness of space, there is a structure, a sense of belonging, and a force that keeps everything in its right place. You are safe within this web, resting here on Earth, which is itself Tucked away in a quiet corner of this magnificent arrangement, everything is held in a state of perfect, rhythmic balance. But as we look even closer at the way our galaxy moves, noticing how the stars at the very edges orbit the center just as quickly as those closer to the heart, we begin to realize that even this magnetic web and the gravity of all the stars we can see are not quite enough to hold the galaxy together. There is something else out there, something much larger and even more mysterious, hidden in the deepest shadows of the universe. It is perhaps the greatest secret of our galactic home, a vast, invisible container that surrounds us all, known as the dark matter halo. Imagine, if you will, that everything we have discussed so far, the hundreds of billions of stars, the glowing nebulae, the massive black hole at the center, and the vast clouds of interstellar dust, is only a small part of the story. While the Milky Way looks like a complete and self-contained island of light, it is actually nestled inside something much larger and far more mysterious. Scientists call this the dark matter halo. It is a vast, invisible sphere of influence that extends far beyond the furthest stars of the spiral arms, acting as a silent, cosmic foundation for everything we see. When astronomers watch the way our galaxy rotates, they notice something that seems almost impossible. The stars at the very outer edges of the galaxy are traveling at nearly the same speed as the stars closer to the center. By the standard rules of gravity, those distant stars should be moving much slower. Without enough mass to hold on to them, they should simply fly off into the deep dark of intergalactic space, like water droplets spinning off a wet wheel. But they don't. They stay perfectly in their orbits, held by a force that is much stronger than the light of the stars alone can explain. This is where the dark matter halo comes in. We now know that the stars and gas we can see make up only a tiny fraction of the Milky Way's total mass. In fact, about 85% of the gravity that holds our galaxy together comes from dark matter. It is a substance that does not emit, absorb, or reflect light. It doesn't glow like a star, and it doesn't block the view like a cloud of dust. It is truly invisible, passing through everything, including us, without leaving a trace. We only know it is there because of the gentle, persistent pull it exerts on the stars, keeping them gathered in their beautiful rhythmic dance. Take a moment to visualize this. Imagine the bright spiraling disk of the Milky Way as a small glowing jewel set inside a massive, transparent orb. This orb, the dark matter halo, is the giant, invisible container that keeps the spiral from flying apart. It is a comforting thought in its own way that even the parts of the universe we cannot see or touch are working together to maintain order and stability. This halo acts like a soft, heavy blanket draped over the entire galaxy, providing the weight and the structure needed to keep our cosmic home intact. It is the silent guardian of the spiral, a vast and ancient presence that was likely there long before the first suns began to shine. As you lie there, perfectly still and relaxed, you can feel the scale of this invisible architecture. You are resting on a planet, orbiting a star, within a galaxy that is itself cradled by this immense dark anchor. Everything is held, everything is secure, and everything is exactly where it needs to be. But as we drift toward the outermost boundaries of this halo, we begin to see that the Milky Way is not a lonely traveler. As we look just beyond our own borders into the true deep space that lies ahead, we discover that our galaxy has companions, smaller, shimmering neighbors that follow us through the void like loyal friends. As we drift past the invisible boundaries of our own galaxy's halo, moving into the deep velvet silence of intergalactic space, we find that the Milky Way is not traveling through the void alone. Just as planets have moons that follow them in their journey around a sun, our galaxy has its own faithful companions. These are the satellite galaxies, and the most famous among them are the large and small Magellanic Clouds. Imagine looking up at a perfectly dark night sky from a quiet, remote spot in the southern hemisphere, perhaps the high deserts of Chile or the vast, still plains of Australia. While the rest of the world sleeps, you might notice two hazy, glowing patches of light that look like soft, permanent clouds caught in the stars. Unlike the clouds in our own atmosphere, these do not drift with the wind or dissipate with the morning sun. They stay fixed, glowing with a gentle ancient light that has traveled across the vacuum of space for nearly 200,000 years to reach your eyes. These are not clouds of water vapor, but entire galaxies in their own right, containing billions of stars, vast nebulae, and their own mysterious worlds. They are called irregular galaxies because they lack the neat, organized spiral arms of the Milky Way. Instead, they look like soft, glowing splashes of light, almost as if a celestial artist had flicked a brush against the dark canvas of the night. For centuries, travelers and stargazers have looked at them and wondered if they were detached pieces of the Milky Way itself, small fragments of our own river of milk that had somehow drifted away into the dark. In a way, that feeling of connection is scientifically accurate. The Magellanic Clouds are bound to us by the invisible threads of gravity. They orbit the Milky Way in a slow, majestic circle that takes billions of years to complete. As they move, they interact with our galaxy's outer edges, trailing long streams of gas behind them like the gossamer ribbons of a kite. This interaction often triggers the birth of new stars within them, creating brilliant nurseries of light that shimmer within their hazy borders. Take a slow, deep breath and consider the comfort of this cosmic arrangement. Even on the scale of galaxies, structures so vast they defy human imagination, there's a sense of companionship. The Milky Way is the center of a small, loyal family of nearly 60 smaller galaxies, all moving together through the immense darkness of the universe. We are not a solitary island in an infinite ocean. We are part of a community, a collection of light bringers huddled together in the deep. The large Magellanic Cloud, the closer of the two, sits about 160,000 light years away. It is home to the Tarantula Nebula, one of the largest and most active star-forming regions ever discovered, a place where gravity is constantly weaving new suns into existence. The small Magellanic Cloud sits a bit further out, at 200,000 light years, a smaller but equally beautiful neighbor. They serve as a reminder that even in the most remote corners of space, there is activity, there is growth, and there is light. As we leave these small, glowing companions behind and look even further into the distance, we begin to see a light that is different from anything we have encountered so far. It is a faint, elongated smudge of brightness, barely visible, but undeniably present. It is the light of our great neighbor, a galaxy that matches our own in size and majesty. As we turn our gaze toward this distant glow, we are looking across the true abyss toward the Andromeda Galaxy, the sister of the Milky Way, waiting for us in the deep stillness of the night. Gaze further now, past the small, loyal satellite galaxies that cling to our borders and out into the truly deep void. There, floating in the velvet stillness of the distant universe, is the Andromeda Galaxy. Astronomers often call it M31, but to us it is simply our great neighbor. It is our sister galaxy, a mirror image of our own home, yet scaled up to an even more majestic size. Take a slow, quiet breath as you consider the distance between us. Andromeda sits approximately 2.5 million light years away. This number is so large it feels abstract, but try to imagine the journey that light must take to reach us. The soft glow of Andromeda that hits your eyes tonight began its journey through the darkness 2.5 million years ago. It has been traveling through the vacuum of space since a time long before the first modern humans walked the earth. It is an ancient light, a message from the deep past, arriving just in time for you to see it. In a truly dark sky, far from the city lights, you can see this galaxy with nothing but your own eyes. It appears as a soft, ghostly smudge of light, a faint thumbprint on the fabric of the night. It is a profound realization to know that you are looking at the most distant object visible to the naked human eye. Your vision is crossing a bridge of 2.5 million light years, touching the collective glow of 1 trillion suns. While our Milky Way is vast, Andromeda is even more expansive. It is estimated to hold nearly 1 trillion stars compared to our few hundred billion. It is a massive, swirling disk of light, gas, and dust, organized into elegant spiral arms that mirror our own. If you could see it clearly, it would span several times the width of the full moon in the sky. It is a giant, silent companion in the dark. There is a beautiful slow-motion story unfolding between our two galaxies. We are not just neighbors, we are partners in a cosmic dance. Gravity is pulling the Milky Way and Andromeda toward one another at a steady pace. Though we are separated by an immense gulf, we are drifting together, closing the gap by hundreds of thousands of miles every hour. But do not let the idea of a collision disturb your rest. In the scale of the universe, this is a peaceful event. Because stars are so far apart from one another, when our galaxies finally meet in about 4 billion years, they will not crash. Instead, they will flow through each other like two clouds of mist passing in the night. They will mingle, their stars finding new paths and new rhythms, eventually settling into a single, massive, glowing, elliptical galaxy. It is a graceful merger, a union of two great families of stars. Imagine the sky of that distant future, filled with the light of two galaxies overlapping, creating a canopy of stars so bright that the night would never be truly dark again. For now, however, Andromeda remains a quiet, distant beacon, a reminder that even in the vastness of space, we have a sister galaxy watching over us from across the void. We are part of a larger story, a slow and beautiful movement toward a future where two rivers of light become one. As we pull our gaze back from this distant sister, we begin to realize that Andromeda and the Milky Way are not alone in their journey. They are the two largest members of a small, tight-knit community of galaxies, a cosmic village that travels together through the expanding universe. As we move deeper into the stillness, it is comforting to realize that the Milky Way and Andromeda are not solitary wanderers in the dark. They are the two primary anchors of a small, intimate gathering of galaxies known as the local group. This is our cosmic neighborhood, a collection of about 50 galaxies that travel through the vastness of space together like a small fleet of ships crossing a calm, dark ocean. While the Milky Way and Andromeda are the undisputed giants of this group, the neighborhood is filled with smaller, humbler members. Most of these are dwarf galaxies, collections of stars that are much smaller and less organized than the great spirals. They often huddle close to their larger companions. We have already spoken of the Magellanic Clouds, those soft smudges of light that orbit our own galaxy. But there are many others, like the Leo 1 dwarf or the Cetus dwarf, each a quiet pocket of stars drifting in the periphery. Then there is the Triangulum galaxy, the third largest member of our group. It is a beautiful, smaller spiral located about 3 million light years away. If the Milky Way and Andromeda are the parents of this local family, Triangulum is like a younger sibling, smaller and more delicate, yet possessed of its own intricate beauty. It is a place of active star formation, where new suns are being born in colorful clouds of gas, adding its own soft glow to our local corner of the universe. Astronomers often call this collection of galaxies our cosmic village. It is a fitting name. In the grandest scale of the universe, space is expanding, pushing distant galaxies further and further away from one another at incredible speeds. But within our village, gravity is stronger than that expansion. It acts as an invisible bond, a gentle tether that keeps us all together. While the rest of the universe rushes away, the local group remains a stable, enduring sanctuary. We are part of a community that will stay together for billions upon billions of years. Take a moment to feel the scale of this. You are resting in your room on a planet that circles a star which resides in a galaxy which is part of this small, quiet village. There is a profound sense of belonging in this realization. The universe is vast, yes, but you are not lost in it. You are situated within layers of structure, each one cradling the next. You are a citizen of a cosmic neighborhood, held in place by the same fundamental forces that keep the stars in their orbits. As you breathe slowly and deeply, imagine these 50 galaxies drifting together through the void, their collective light, creating a warm, soft glow in the darkness. They are silent, they are ancient, and they are our companions. Even in the deepest reaches of space, there is a sense of home. But how let us turn our focus back toward our own front door. We have journeyed far, looking at the neighbors and the distant sisters, but the Milky Way still has stories to tell. As we return to the familiar curves of our own spiral arms, we begin to notice not just where we are, but how we are moving. Our galaxy is not a static object. It is a living, rotating wheel of light. And as we settle back into the familiar glow of our own stars, we prepare to understand the great rhythm of the galactic year, the slow and steady heartbeat of our home. As we return our gaze to the familiar curves of our own spiral arms, we begin to feel the rhythm of a much larger clock than the one on your bedside table. This is the heartbeat of the galaxy itself, a measurement of time so vast it hums beneath the surface of history. We call it the galactic year, or sometimes the cosmic year. Just as the Earth takes 365 days to circle the Sun, our entire solar system, the Sun, the planets, and all of us, is engaged in a much grander orbit, circling the glowing heart of the Milky Way. Imagine, for a moment, the last time our Sun was in this exact same position in its galactic journey. We would have to travel back roughly 230 million years. At that time, the world looked nothing like it does today. The very first dinosaurs were only just beginning to appear on the surface of the Earth. The continents we know, Africa, the Americas, Europe, were all huddled together into one giant landmass called Pangaea. Since that moment, the Earth has seen the rise and fall of entire eras, the shifting of oceans, and the birth of every human who has ever lived, all while the Sun was making its way through just one single silent lap around the galactic center. In the time it takes for you to take a slow, deep breath, we are covering an immense distance. To complete this orbit within 230 million years, we must travel at a staggering speed, nearly 500,000 miles per hour. We are hurtling through the dark, yet the motion is so perfectly balanced, so incredibly smooth, that as you lie there, you feel nothing but the stillness of your room. It is a cosmic paradox. We are travelers on a high-speed journey across the stars, yet we are held so securely by gravity that we can drift off to sleep in perfect peace. The galaxy is a grand slow-motion carousel. It is the smoothest ride imaginable, a journey where there are no bumps, no sudden turns, only the eternal, steady glide of stars through the void. We are anchored to our Sun, and our Sun is anchored to the galaxy, creating a sense of safety that spans across light years. You are not just lying in a bed on a planet. You are a passenger on a magnificent glowing vessel, sailing through the deep time of the universe. As we reflect on this movement, we see the Milky Way not just as a collection of distant objects, but as a living masterpiece of light and motion. It is a river of stars that flows through the ages, carrying us along in its gentle, steady current. We are part of this grand rotation, a tiny but vital spark in a wheel of light that has been turning for billions of years and will continue to turn long after we have finished our rest. Our home is vast, ancient, and breathtakingly beautiful, a sanctuary of light in the velvet dark. As we settle into this final stretch of our journey, let the scale of the galaxy wrap around you like a heavy blanket. We have traveled from the bright, crowded center to the lonely, drifting edges, and now we prepare to look back one last time at the river of stars that has guided us home. Take a final look with your mind's eye at that shimmering river of light, stretching from one horizon to the other. This is the Milky Way, our magnificent, glowing home. We have traveled a vast distance tonight, journeying from the very heart of the galaxy to its soft, silent edges. We have seen the crowded golden light of the galactic bulge, where stars are packed so tightly that the night never truly falls. We have peered into the invisible center, finding comfort in the steady gravitational anchor of Sagittarius A, the quiet giant that keeps our cosmic family together. We moved outward through the great spiral arms, tracing the paths of the Scutum Centaurus and the Perseus arms, witnessing the birth of new suns in the colorful nurseries of the nebulae. We met the brilliant, short-lived blue giants that illuminate the dark like beacons, and the humble, ancient red dwarfs that will continue to glow softly for trillions of years to come. We passed the lonely, drifting rogue planets, wandering peacefully through the interstellar mist, and we looked upon the cosmic soot of the Great Rift, realizing that even the shadows in our galaxy are made of the building blocks of worlds. As we linger here in the quiet of the Orion Cygnus arm, our own little corner of the universe, there is one final truth to carry with you into sleep. Every atom that makes up the world around you, and every atom within you, was once forged inside the heart of a star. The iron in your blood, the calcium in your bones, and the oxygen you are breathing in right now were all created billions of years ago in the same stellar furnaces we have visited tonight. You are not a stranger to the galaxy. You are a part of it. You are the universe experiencing itself. A small, precious spark of consciousness wrapped in the same stardust that forms the pillars of creation. The vastness of the Milky Way is not a cold or empty thing. It is a warm, ancient cradle that has been tending to life for eons. The same laws of physics that guide the stars in their multi-million-year orbits are the same laws that keep your heart beating and the air moving gently in and out of your lungs. There is a profound safety in this scale, a realization that you are held within a system so large, so stable, and so beautiful that you can let go of every earthly worry. Bring your focus back now to the room around you. Feel the gentle weight of your blankets like a soft layer of stardust settling over you. Notice the rhythm of your breath, as steady and reliable as the rotation of the galaxy itself. The ceiling above you is no longer a barrier. It is a gateway to the velvet sky we have explored. The darkness is not empty. It is full of peace, full of history, and full of light that has traveled across time just to reach you as the stars continue their silent, graceful dance above. Let your mind drift into the deep, restorative stillness of the night. You are home. You are safe. You are part of the grand, glowing river of stars. Sleep now in the quiet embrace of the galaxy. Sweet dreams, deep, star-filled sleep. Good night.